All right, so let's look at what we have in this particular problem. I'm going to rewrite it, and so I am going to multiply the exponent so I see what I've got in the denominator. So I've got x to the 4th, y to the 8th. So I want to multiply by the least common denominator, which is going to be x cubed. So multiply top and bottom by x cubed. So distributing, I get 1 for the first term. Distributing this to this term, I'll get 2x squared. Then here on the denominator, I'll get x to the 7th, y to the 8th. And that's as simple as it gets, but I've gotten rid of the complex fractions. All right, ooh, look at these negative exponents, fractions, lots going on here. So this is 3, and I'm just going to rewrite this as x to the 1/2. This is positive 4, and I'd have x to the 3/2 in the denominator. And then here I'd have 1 over x to the 1/2. All right, so let's think about what the least common denominator will be. So between all these three terms, x to the 3/2 will be the least common denominator. All right, so if I multiply this times this term, adding the exponents, I'll get 3x squared. Multiplying this times this term, I will just get 4. Multiplying this times this term, I'll subtract 1/2 from the exponent of 3/2, so I'll get x to the 1 power. And that's much more simplified. And I do believe this is the exact, oh no, it's not almost the same problem as number 5, but not quite. All right, so let's multiply top and bottom by x squared minus 1. I'll just leave it like this because we see the difference of squares, right? So if I need to, I'll break it up. All right, distributing this to this term, I'll get 1. Distributing this to here, I'll get x minus 1. In the denominator, here, this times this gives me x times x squared minus 1. And this to this term will give me a plus x plus 1. So the numerator, I can see I'll get a 2 plus an x. And the denominator, never multiply it out. It's not ever going to be useful, so just leave it as it is. All right, here I see this has got some negative exponents, so 4y squared, and I'll put that in the denominator as x to the 1/4, x to the 3/4, and then times a y. So they wanted me to put it together. So if I want to make common denominators, I need to multiply this top and bottom by x to the 1/4. So this one stays the same. So this, if I multiply x to the 1/4 times this gives me x to the 4/4, and that's just x. And there's x to the 1/4 in the denominator. So this gives me 4y squared minus 3xy over x to the 1/4. Almost done here. All right, so this is very similar to what we just did. Is it the same? I think it's the same problem. Yes, it is. Look at that. 6 and 8 are the same, so let's just skip that. And this, oh no, it's not the same. I've got a 1 plus now. So let's investigate. Okay, so no, it's not the same. This one has an adding on 1. So first off, I'm going to rewrite it, putting the negative x's in the denominator. It looks like this. All right, so now I'm going to multiply top and bottom by x to the 3/2. So distributing this to here, so I'll get 3x to the 4/2, or squared. This to this gives me a 4, because they'll cancel. This to this gives me x to the 3/2. And this to this, I'll subtract 1/2 from the 3/2, so I'll get x to the 2/2, which is just an x. And this one's similar again, but not quite, so I'm just going to take the time to rewrite it. So 2 root x plus 4 over root x 3 plus 2 over x to the 3 halves. Okay, doing lots of these because this is just kind of algebra that you'll need to do, so I want to make sure you're comfortable with it. So multiplying top and bottom by x to the 3 halves. So getting rid of the fractions. This is using the least common denominator. So multiplying this times this gives me 2x squared. This to this gives me 4x. And this distributed here, 3x to the 3 halves. And then this to this just gives me a plus 2.